Hey Shahmi, have you ever thought about going to South America?
Depends. What part are we talking?
Montevideo. I saw some picture online, such as food and culture, that looks amazing.
Montevideo? That's the capital of Uruguay, right?
Exactly. And guess what? Almost half of the entire country's population live there. That's blew my mind.
That makes sense. Actually, Montevideo isn't just a capital. It's a heart of Uruguay. Politically, culturally, and demographically.
Wait, demographically? You are going to research more again?
Well, funny you said that. I'm actually doing a presentation on the population of Montevideo. It's crazy how the city grew over time and become such a central hub.
Oh, so this world trip is your sneaking way to introduce your school project?
Guilty! But hey, if we're going to talk about Montevideo, why not make it fun? Ready to learn more?
Bring it on!
Everyone, today I'd like to take you on a quick journey to the heart of Uruguay, the city of Montevideo, known for its cultural richness and vibrant lifestyle. Montevideo is not only the capital city of Uruguay, but it is also the home to nearly half of Uruguay's entire population. In this video, we will explore how the population grown and changed over the years, and what factors influence the population. So, let's dive into our video.
The world population will be 8.09 billion in 2024? Oh my god! But what is population,
Population refers to the complete set of individuals, items, or data that share a common characteristic and the focus of a study. Representative sample is selected to conduct analysis and draw conclusion. It is from this entire group.
This is table of data population in Montevideo. As you guys can see, from 2005 until 2024, the population is increased. Wow, this is incredible! By using Excel, we can plot a graph using data of population in Montevideo. The graph will increasing. Alisa, how to get particular solution?
Don't worry, Ifa. I got you.
What is that?
So, based on the general equation that we got, we can substitute the value of t and the value of p. T is the year, while p is the population in Montevideo. So, we can get the value of A.
Oh, so to find the value of k, we need to substitute the value of t and p like we did to find the value of a.
Yes, so after you got the value of k, you can substitute it into the general equation. So, we can get the particular solution.
This is the particular solution.
Yes,
Oh, now I know. Thank you, Arisa.
you're welcome. For the predicted past value, we choose 2034, and this is what we got for the past value.
For the future value, we choose 2027, and the value we got is ta-da!
So this is the exponential graph of the particular solution, full version. And for the zoom in version, as you can see, the graph does not touch the horizontal asymptote. This is table of data population comparison
In Montevideo, between actual value
and particular solution
from 2005 until
2034.
The value that calculated from particular solution seems to be close to the actual value, but it still have a small difference, may caused by several factors. But before we go through our discussion, I would like to talk about the percentage error. Here is the percentage error that we calculated based on 2024, which is only 0.0067%. The main reason why our predicted value and actual value is not accurate is unexpected events such as COVID-19 that affect the population in 2020 until 2022. Okay, now you know why actual value and predicted value is not accurate. But people also ask, what has affected the population growth in the past? Let me walk you through this. Okay, first, healthcare improvement. Montevideo is a home of several notable hospitals that offer a good treatment for a patient. As a result, it can reduce the death rate and increase the life expectancy. As you can see here, this is life expectancy in 2005, which is 75.8, and here is life expectancy in 2023, which is 78.1. Next is economic development. Since Montevideo is the capital city of Uruguay, it provides a lot of job opportunity to people. So people here can live in a sufficient life. Okay, so now you already know what has affected the population growth in the past. Next, we will go through what will affect the population in the future. Okay, now I will introduce you to things that might affect population in the future. First of all, is climate change. As we know, climate change can give a lot of negative impact to the city. For example, rising sea levels. It also can cause a lot of natural disasters such as flood and can affect the food availability. Besides that, more improvement in healthcare also can affect population in future. With ongoing technology advancement, Montevideo could see a significant improvement in healthcare. Indirectly, it can treat a chronic disease better and can reduce death rate.
All in all, for task 1, we can see from 2005 to 2024, all of the population is increasing. Then, the plotted graph shown that a tally result for the statement. From the discussion, the predicted population is close to the actual 2024 data, with a small error, which is 0.0067%. The difference may be caused by events such as COVID-19. In the past, healthcare and economic growth boost the population. For the future, climate change and medical advance may shape the population trends. Okay, now let's find a root of a function using Newton-Raphson method. This is the equation of the Newton-Raphson iteration. For the fx, we need to find it using the equation. This is the equation that we get. Okay, for the initial approximation, which is x1, we use midpoint as the value. Why we use midpoint? We use midpoint because of the intermediate value theorem. This theorem says if a function is continuous and if fa and fp have opposite signs, the function has cross zero between a and b. In other words, the root has to be in the interval.
Okay, now we are going to find the root using Newton-Raphson method by using Microsoft Excel. Okay, first we have to arrange x, fx, f prime x and Newton-Raphson iteration formula in a row. Then we put the initial approximation, which is 5.5, below the x column. Next to the initial approximation column, we substitute the value of fx, which is x minus 3 square plus exponent negative 3x minus ln x cubed. Next to the fx column, we substitute the formula of f prime x, which is 2 in bracket x minus 3 minus 3 exponent negative 3x minus 3 over x. For the last column in the row, we substitute the Newton-Raphson iteration formula, which is x minus fx over f prime x. For the next root, we use the answer we got from the Newton-Raphson iteration formula just now, and we substitute in the column. For the next fx value, we just have to drag the first fx row to the second row, and the value will be automatically calculated. For the next step, we just use the same step as before until we got the stable value of roots.